Now, for some schools itself, right, they actually learn what we call resolution of vectors itself. So basically, this is the calculation portion of your vectors. So instead of using a skilled diagram or using the drawing itself to actually identify and kind of estimate what's the resultant vector, we're actually going to use trigonometry. Basically, our trigo itself to actually solve what is your resultant vector. So before we go on to there, let's ask ourselves first. If I have a diagonal vector, what happens is you can actually split it into its horizontal and your vertical component. What I mean by this is, for example, is f is like this. What I can say is I can break it down into a horizontal. Okay. And you can break it down into a vertical. So in the end, what this means is basically you can treat your diagonal vector as a resultant of a horizontal and a vertical component of the of two forces. Okay, so you'll notice that you have your f cosine and you have your f sine, right? Basically, these are your trigonometry, because if you notice, if I just take sine theta, normally it's opposite over adjacent, right? Sorry, opposite over hypotenuse. So what is your opposite? Opposite is what we have, which is what we're trying to find, right? So we're trying to find what is opposite. So basically it's hypotenuse times sine theta. And what is hypotenuse? Hypotenuse is your f. So it's f sine theta, which is your blue color over here. Okay? So basically you can just imagine that if you have the value, you have 350 and 35 degrees, for example, you can actually just put in the numbers and you can solve what is what. Okay, so if you were to do Pythagoras theorem, you can actually get back the same value as well. And if you notice all of those, okay? So basically, each diagonal vector can be broken down into your vertical component and your horizontal component itself. Okay, so we'll actually make full use of this itself. We actually use your trigo. So each vector will break it down into horizontal and vertical components. So if I have two vectors, all I need to do is break it down into its vertical and horizontal components, add up the two verticals, add up the two horizontals, and then after I have the two values, all I need to do is just use Pythagoras theorem to find my hypotenuse. And if I want to find the angle, all I need to do is use my tangent, okay, to actually solve for the value itself. So let's take a look at the word example on the next page. Now, vector number one, you fly 10.0 southeast, and then they tell you have another southwest. This is number two. So what's the direction of a magnitude of my duck, right? So direction and magnitude of this velocity of the duck. So this is your resultant. So first thing, vector number one. We have a 10 meters per second southeast. So southeast will be in this direction. Okay. So what you want to do is you want to break it down into its individual components itself. So the first thing you want to do is you want to find, okay, maybe I use a different color. So the first thing you want to find is your horizontal component and your vertical component. Okay, so you have your two values over here, and they tell you that this is 45 degrees southeast, right? Which means this is 45. Southeast means it's 45 degrees. So basically, this is 10.0, correct? So what we have on top here, because it's adjacent, this is 10.0 cosine 45. And for your blue color, is 10.0 sine 45. Okay? And then for your second vector itself, they tell me that this is now southwest. So it's 2.5 southwest. Okay, now these are not drawn to scale. Basically, we don't even need to draw the diagram as long as you understand how you break it down. But basically, this is just to show you which is which. Okay, so this part over here, same thing, is still 45 degrees. So what you want to do, this is 2.5. So all you need to do, same thing, this is cosine as well. And if you notice over here, because you're in opposite directions, what you can write is this is actually a negative cosine. Okay, and because downwards, let's take downwards to be the same positive, you can actually end up with sine 45. Okay, so you can see over here, you can choose the direction to be, which direction is to be positive, as long as you have opposite directions. So you can see over here, my horizontal components, they will actually cancel out. But for my vertical components, they'll actually add up together because they're in the same direction with color opposite direction. So all you need to do now is just throw in the numbers. Okay, so horizontally, you have your 10 cosine 45. And on your other side, you have 2.5 cosine 45. So take a calculator, press the values in, 10.0 cosine 45, close bracket, minus 2.5 sine 45. So you end up with 5.3 something, 5.3033. Okay, this is meters per second, so we just keep it as is for now. And then we'll do the same for your vertical component. So 10.0 sine 45, 2.5 sine 45. So you want to add them both up. 10.0 sine 45 close bracket plus 2.5 sine 45 close bracket. So you end up with 8.8388 meters per second. So now if I want to find my resultant vector, all I need to do is use Pythagoras theorem. A squared plus B squared equals C squared, right? So all I need to do is take all I need to do is take my 5.3033, I square it, and I add up 8.8388, I square it, equals to my resultant squared. So if I want to find my resultant, all I need to do is just square the two values. Okay, so I'm just gonna put this inside. Both. So just write square root 5.3033 square plus 8.8388 square. They end up with 10.308. And because this is our final answer, we're just going to use 3SF for this. Okay, because on top everything is 3SF. You can see these 2SF. You can also use 2SF. So if you use 2SF, you end up with you use 2SF, you end up with 10 meters per second 2SF. Okay, now if you continue to solve, because don't forget they want direction as well. So for direction, we don't use your drawing itself. We actually use tangent. Now, why do we use tangent itself? You'll notice that we use tangent is because we only know your horizontal and your vertical. We don't know your hypotenuse, because don't forget, this 10.308 is actually a estimated value. Okay, so best to actually write your opposite over your adjacent. So to solve this, all you need to do is we'll take your adjacent, opposite. Opposite itself will be your the opposite will be the 8.8388 over your 5.3033. Okay. Then what you want to find is theta, right? So what you want to do is take tangent inverse. Okay, tangent inverse of the above. We take tangent inverse of this value. So we equal this tangent inverse 8.8388 over 5.3033, close your bracket, you should end up with 59.036. And because this is an angle, we'll take 59.0. Okay, we use one decimal place. Let me just quickly check if the values are correct. And yep. So how to answer the question? Same thing in the same format. You want to say that your resultant, because this is speed, right? So in this case, it's resultant velocity. We will say resultant velocity is 10 meters per second, and it is 59.0. And if you notice, this will be southwest. So southwest, you can say that this will be below the horizon. Okay. So you can see, if you were to quickly sketch it out, you'll notice that you have to the right and you have it to the east and to the south. So because don't forget, our east, south, and east is positive. Since we have positive values, it is southeast. So this is will be 59.0 below the horizontal or 59 degrees from the from yeah. So actually you can say it is from the horizontal. No, doesn't make sense. So just right below the horizontal to get your resultant velocity. So in this case, we can use calculations to actually help us solve for any kind of vector diagrams. So instead of drawing it out, you don't even need to draw it out. Once you're able to kind of picture in your head, right? But actually it's better to kind of sketch it out, so that at least we know which side is sine, which side is cosine. Because some students tend to make the mistake where they are not sure where's sine, where's cosine. So better to just do a quick sketch. Same thing for this. If you know you have a horizontal of your 5.3033 and you have a downwards vertical of 8.8388, don't forget your resultant will be this. So your theta will be this one over here. So ask yourself, when you want to use tangent, which one is your opposite, which one is your adjacent? Because some students tend to may make the mistake of actually flipping the numbers. So if you were to flip the numbers, if you flip the numbers itself, you actually end up with the other side instead. So in the end, you end up with this side, which is wrong. Because remember, we are always gonna take from your resultant. If your resultant start from here, we're gonna take from this side of the angle. Okay, so that's all for the additional part of your resolution of vectors, your scalars and vectors. Not all schools will have this part, so only if and only if your school part teaches this, you a bit more familiar with how you actually solve this. So just take note. That's all.